Welcome to the Deep Dive. Today, we're tackling something absolutely central to anyone building or securing software, JFrog Artifactory.
It really is, isn't it? Since, 2008, it's become this cornerstone.
Exactly. It's the universal repository manager. And for so many companies, it's not just helpful, it's the vault.
Yeah.
The digital vault for every binary, every container image, every dependency they touch.
Absolutely. And when we say universal, we really mean it. It supports, I think the count is over 40 package types now. Everything from the classics like Maven and Docker through to Helm, NPM.
And even AI and ML models, right, which are getting massive.
Exactly. Huge, complex models.
Yeah.
Basically, if you need a component to build or run software, chances are it's managed through Artifactory in a modern setup.
So today's deep dive is all about securing that digital factory floor. We've got a stack of material architectural docs, CVE reports, incident analyses.
Yeah, quite a bit to unpack.
Our mission is to really get under the hood. We'll look at the architecture, break down the security features, list out the scariest vulnerabilities and exploits we've seen.
And crucially, look at actual real-world incidents. What really happens when things go wrong? That's where you learn the most, I find.
Definitely. Because there's this core paradox, isn't there? You need Artifactory for speed, for governance, for just knowing what's in your software.
Essential for DevOps velocity, no question.
But that central role makes it target number one. If Artifactory gets compromised, well, it's the keys to the kingdom. It can trigger a massive cascading supply chain attack.
A single point of failure that can ripple out everywhere, potentially right into your production cloud systems. It's that serious.
And here's maybe the most important takeaway up front, something you, the listener, really need to grasp. The biggest risks. They're often not these super complex zero-day exploits.
No, not usually. The research is pretty clear on this.
It's the simple stuff, right? Common misconfigurations, policy mistakes, just dangerous default settings that haven't been changed.
Exactly. It often comes down to operational discipline, maybe more than inherent platform flaws. That's the real battleground.
Okay, let's start with that architecture then, because understanding how it works tells us where the weak points might be. It's way more than just a file share.
Oh, absolutely. It's a sophisticated piece of engineering. It's built using a modular microservices-based design. The whole point is high availability, HA, and scaling across different environments, cloud, hybrid, on-prem, wherever.
So modular means it's resilient.
That's the idea. It uses this node-based structure. Think of each node as having, a set of core functions. Inside each node, you've got the microservices doing the work, handling metadata, processing artifacts, and importantly, a local router.
A router within the node.
Yeah, acting like a local API gateway. It directs traffic within the node, helps services find each other. It means if one part has an issue, or even if another node goes down, the system can keep routing requests effectively.
Okay. And the storage itself, the file store as they call it, that's not just dumping files, is it? The sources talked a lot about checksums.
Right, the checksum optimized storage. This is key. It uses things like SHA 256 hashes. Every single artifact isn't just stored by its name. It's stored and identified by its unique cryptographic hash. It's fingerprint, essentially.
That's for integrity, obviously, making sure it hasn't been tampered with.
Exactly. If the checksum matches, the file is good. It's the foundation of trust in the artifacts.
But there's a huge efficiency win there, too, isn't there? That deduplication concept. Can you explain that simply?
Sure. Imagine you've got, say, thousands of developers in a big company, maybe hundreds of different projects, all depend on the exact same version of a common library, like Log4j version 2.17.
Okay, happens all the time.
Right. So if 100 different build pipelines request that exact same Log4j binary, Artifactory doesn't store 100 identical copies. Because the SHA 256 hash is identical for all of them, it stores the binary once.
And just points everything else to that one copy.
Precisely. Just uses references. This deduplication, according to the materials we looked at, can cut raw storage needs by like 50 to 70%, sometimes even more. It's a massive saving baked right in.
That's clever. Okay, so how do these pieces fit together? The sources mention 4 main architectural layers for performance and isolating failures.
Yeah, they layer it logically. First up, you've got the ingress or edge layer. This is purely about handling incoming traffic. Think load balancers, maybe NGINX, AWS application load balancers, that sort of thing. They handle SSL, route requests to the right internal node.
And maybe some caching right at the edge.
Sometimes, yeah. Especially for speeding up access for remote teams. Basic stuff, but essential.
Then inside that, you have the application layer. The engine room?
Pretty much. This is where the core services live. processing uploads, handling download requests, and critically, indexing all the metadata, who built what, when, from which source code commit, all that vital tracking info.
And this layer is clustered for resilience.
Yes, and importantly, it's designed to be stateless. The application nodes themselves don't hold on to critical, persistent data. They just process requests. So if one node fails, the load balancer just sends traffic to the others. Users ideally shouldn't even notice.
Which implies the state, the actual data, lives deeper in the data layer.
Exactly. This is where the persistent file store lives, often backed by S3 or maybe some high-performance network storage, and the database. The database holds all the metadata, user permissions, configurations, the shared state of the cluster.
And PostgreSQL is the recommended choice there, right, for serious deployments?
Yeah, especially for HA setups. Its features around replication, failover, robust backups, they're crucial for hitting that high availability target, like the 4 nines, 99.99% uptime goal many enterprises aim for.
Okay, final layer, the integration layer, connecting to the outside world.
Right. This is how Artifactory talks to the rest of the DevOps universe. It supports a huge number of plugins, over 100 community and official ones, for CI/CD tools like Jenkins, GitLab, Azure DevOps, you name it.
And it uses queuing systems for that.
Often, yeah. Things like RabbitMQ. It uses asynchronous queues to handle the massive flood of requests coming from potentially thousands of concurrent builds uploading and downloading artifacts. It stops the core system getting swamped.
That HA design sounds really robust. Load balancer, clustered stateless app nodes, shared durable database. But what about global companies, teams in different continents?
Yeah, geoscalability. That's where federation and replication come into play. They sound similar, but they solve different problems.
Okay, break that down. Replication first.
Replication is generally simpler, often asynchronous. Think of it like a central master site, pushing artifact changes out to various edge sites around the world. The main goal is putting the binaries closer to the developers or servers that need them, reducing download times.
So my team in Sydney pulls from an Australian replica, not all the way from the US.
Exactly. It's about consumption speed. But the sync is usually one way, or at least primarily one way. It's less about collaborative development across sites.
Which is where federation comes in.
Right. Federation is designed for true multi-site collaboration and ensuring strong consistency. It provides bidirectional synchronization. If a developer in London updates an artifact in a federated repository, that change gets synced automatically to the federated repositories in New York, Tokyo, wherever.
So everyone, everywhere, is working with the exact same version.
That's the goal. A single, consistent, reproducible software supply chain, globally distributed. Critical for large, complex projects.
That sounds powerful, but that bidirectional sync, doesn't that create performance challenges? You mentioned database bottlenecks earlier.
It absolutely can. While the architecture handles reads and general traffic well, the writes, especially metadata writes, during peak build times, imagine hundreds of pipelines finishing simultaneously and registering their build info, can really hammer that shared central database.
So how do you deal with that?
Careful tuning. Really meticulous tuning of the database connection pools, ensuring the underlying storage for the database is incredibly fast. Think high-speed NVMe drives, especially in that central HA cluster. It's a common growing pain for large deployments.
Okay, let's pivot to the core function. Managing repositories. This is the heart of Artifactory, where the flexibility lies, but also where a lot of security issues crop up, right?
Definitely. Understanding the 4 main repository types is crucial for security.
Let's start with the most sensitive, local repositories.
These are for your own stuff. Your proprietary code, the artifacts your teams build internally. This is your intellectual property. Security here needs to be absolutely watertight. If these leak, you're leaking company secrets.
Okay, makes sense. Then remote repositories. You said these act as a security checkpoint.
Yes, this is one of Artifactory's biggest security advantages, in my view. A remote repository acts as a caching proxy for public registries. Docker Hub, Maven Central, PyPI, NPM.js, you name it.
So instead of developers pulling directly from the internet,
everything has to come through Artifactory first. It forces all those third-party dependencies to pass through your controlled environment before they land on a developer's machine or in a build.
And the security benefit is you can inspect them first.
Precisely. You can integrate scanning tools, like JFrog Xray, to check every incoming package for known vulnerabilities, CVEs, license compliance issues, even malicious code patterns, as it's being downloaded for the first time. It creates a buffer between your developers and the wild west of public package registries.
Stops that accidental download of a malicious package someone uploaded to NPM?
Exactly. It helps prevent things like typo squatting or dependency confusion attacks from hitting you directly.
Okay, next type. Virtual repositories. These are the ones developers like.
Yeah, they simplify things enormously. A virtual repository lets you group multiple local and remote repositories together under a single URL endpoint.
So the developer doesn't need to know if the library they need is internal or external.
Correct. They just point their build tool, like Maven or Docker, at the one virtual repository URL, and Artifactory figures out where to fetch the artifact from, whether it's in a local repo, cached in a remote repo proxy, or needs to be fetched from the upstream public source.
Convenience is clear, but you flag this as centralizing risk. How so?
Because you've created this single point of access that hides the underlying structure. If you set the permissions on that virtual repository incorrectly, maybe you get broad rate access to all developers, you might accidentally grant them access to a highly sensitive local repository that's part of that virtual group, even if they shouldn't have access to it directly.
So a single permission mistake on the virtual repo can expose more than intended.
Exactly. It concentrates the impact of a policy error. Very convenient, but needs careful permission management.
And finally, federated repositories, which sync bidirectionally across sites.
The security angle here is all about consistency. Because the content is synchronized globally, your security policies, your access controls, your scanning rules must be identical and enforced consistently across all the federated sites.
Why is that so critical?
Because a vulnerability or a misconfiguration in, say, your European federated site could allow a malicious artifact to be uploaded there. And because of federation, that poisoned artifact could then be automatically synced to your primary US repository, potentially ending up in production builds. Global consistency in policy is paramount.
Makes sense. Okay, let's dive into the security architecture itself. It sounds like it's built with enterprise needs in mind from the ground up.
It definitely is. The approach aligns pretty well with zero trust principles. Verify everything, assume breach. It starts with strong authentication and role-based access control, or RBAC.
How granular can that RBAC get?
Very granular. You can control permissions down to the individual repository level, group repositories into projects with specific permissions, and even neutral access based on build information, like only allowing certain pipelines to deploy specific artifacts.
And for user logins? Standard stuff?
All the modern enterprise standards are there. LDAP integration, SAML 2.0 for single sign-on, OAuth and OpenID Connect, OIDC, and critically, support for enforcing multi-factor authentication, MFA, for human users.
What about protecting the data itself, encryption?
Yep. TLS 1.3 is standard for encrypting data in transit between users, nodes, and external systems. And for data at rest within the file store, it uses AES 256 encryption.
Which helps with compliance, I assume.
Absolutely. That level of security control is why they can meet requirements for standards like SOC2, GDPR, and even FedRAMP for government work. They have to cater to organizations with really strict governance needs.
You mentioned integrating with other tools, particularly JFrog Xray. How does that boost the defense?
Xray is JFrog's Software Composition Analysis, or SCA tool. It's designed to work hand in glove with Artifactory. It continuously scans artifacts stored in Artifactory for known vulnerabilities, problematic licenses, and even exposed secrets accidentally baked into the code.
What makes it enterprise grade? Is it just faster scanning?
It's more about the depth and intelligence. One key feature is its contextual analysis.
Okay, what does contextual analysis mean in practice? How does that help?
It helps fight alert fatigue. Imagine Xray finds a library with a known vulnerability. Instead of just flagging it, contextual analysis tries to determine if your specific application actually uses the vulnerable part of that library. Is the vulnerable function even reachable in your code's execution path?
So if you include a library but don't use the dodgy bit, it might lower the alert severity.
Exactly. It can significantly reduce false positives, helping developers focus on the vulnerabilities that actually pose a real risk to their application, rather than drowning them in a sea of potential issues.
That sounds useful. And Xray also helps with finding secrets left in code.
Yes. The Advanced Security Package specifically includes scanning for leaked secrets, API keys, passwords, tokens, hard-coded into artifacts. We'll come back to why that's so critical later.
Okay, but now we need to tackle what the sources called out as possibly the single most common yet critical security failure point in this whole ecosystem, the token trap.
Ah, yes, the token trap. This is such a common way for things to go badly wrong. It's a combination of convenience, maybe some pressure to move fast, and a really dangerous default behavior.
So walk us through the scenario. How does this trap get set?
Okay, picture this. You've got a platform administrator, someone with high privileges in Artifactory. They need to set up a new CI/CD pipeline, maybe for automated deployments. That pipeline needs credentials to talk to Artifactory, right? To push or pull artifacts.
Makes sense. Needs a token or something.
Exactly. So the administrator often goes into the Artifactory web UI, clicks a button to generate an identity token for that pipeline, that machine.
Seems reasonable so far.
Here's the trap. By default, when generated this way through the UI by a high-privileged user, that token inherits the exact same extensive permissions as the administrator who created it.
Wait, hang on. So if the admin has permissions to do everything, manage users, delete repositories, deploy anything the token created for that automated pipeline also gets all those permissions.
Precisely. The token effectively becomes a non-human admin user. And why does this happen? Because it's quick and easy for the admin. They don't have to carefully figure out the minimum required permissions for that specific pipeline and craft a scope token. They just generate one God token and give it to the pipeline. Job done, move on.
Okay, I see the danger. So what happens if that super powerful token gets leaked? And let's be real, tokens leak all the time, committed to Git, left in logs, exposed somewhere.
If that token leaks, it's game over for Artifactory security. An attacker finds that token, and they instantly have full administrative control over your Artifactory instance. They bypass MFA, they bypass all the human login checks. They are effectively that administrator.
And the consequences.
Catastrophic supply chain compromise. They can download all your proprietary source code and binaries, IP theft. They can exfiltrate sensitive data, or, perhaps worst of all, they can upload malicious code, backdoored libraries, Trojanized containers into your trusted repositories.
And the sources really emphasized the link to cloud environments here, didn't they? It's not just about Artifactory itself.
Yeah, critical point. If an attacker gets admin access to Artifactory via a leaked token, what's the first thing they'll do? Download internal artifacts and scan them for other secrets.
Like AWS keys or database passwords embedded in the code?
Exactly. It's incredibly common for developers to accidentally leave cloud credentials, API keys, connection strings inside the artifacts stored in Artifactory. The attacker finds these, and suddenly they've pivoted from compromising Artifactory to compromising your entire AWS production environment or your Azure setup or your databases.
Wow. So the leaked Artifactory token is the key that unlocks the whole cloud kingdom.
It turns a repository problem into a potential company-wide breach. It's a massive concentration of risk, stemming from a seemingly simple operational shortcut using default overly broad tokens. This isn't a flaw in crypto. It's a workflow flaw that encourages bad security practice.
Which makes moving away from those default tokens absolutely priority number one. We'll get to the solution later, but first, let's quantify the threat landscape. Over 35 CVEs since 2018. What are the recurring themes in these vulnerabilities?
Yeah, looking at the CVE history, there's a definite pattern. The analysis showed something like 60% of the significant Artifactory vulnerabilities boil down to improper input validation, as CW20, one of the oldest, most fundamental types of coding errors.
Input validation, basically not properly checking the data the system receives.
Exactly. Not sanitizing or validating data coming in through APIs, file uploads, user inputs. And while it sounds basic, in a system like Artifactory that relies so heavily on APIs for everything, metadata, file paths, user roles, a failure here can lead to really severe outcomes. We're talking CVSS scores of 9.0 or higher.
Why is it so impactful here? What can attackers achieve with bad input validation?
They're constantly probing the APIs, trying to send unexpected data, maybe a malformed HTTP header, a super long string to cause a buffer overflow, or characters like Danny Nay to attempt path traversal. The goal is to trick the system into doing something it shouldn't, like executing arbitrary code, leaking data via SQL injection, or overwriting critical files.
Let's talk specifics. CVE 2024-6915, the cache poisoning vulnerability. That hit a CVSS 9.3. What made it so bad?
Several things. First, it was exploitable by an unauthenticated attacker. They didn't need any login or token. Second, it allowed them to manipulate artifact metadata within Artifactory's cache.
So they weren't necessarily changing the actual artifact file itself.
Not directly. They tampered with the metadata associated with an artifact's hash in the cache. They could essentially make Artifactory's cache entry for a legitimate hash point to or be associated with malicious content or corrupted information.
And the downstream impact.
A disaster for builds. A CI/CD pipeline, trusting Artifactory, requests a normal dependency by its hash. Artifactory serves up the poisoned entry from its cache. The pipeline pulls down the wrong, potentially malicious artifact, believing it's the real thing.
And this was exploited in the wild?
Yes, exploitation was seen around August 2024. It caused real disruption, breaking builds, potentially injecting bad code. It underscores why patching promptly in this case to version 7.90.6 or later is absolutely critical. You can't sit on critical vulns like this.
Another one mentioned was CVE 2024-4142, a privilege escalation.
Right. This one again highlights the danger of input validation errors, but specifically around token creation this time. It essentially allowed a user who already had some access, even very low-level privileges like read-only on one repository, to craft a specific malicious request during token generation.
And that request tricked the system.
It tricked Artifactory into granting that token much higher privileges, potentially even administrative access. It shows how a single flaw can let attackers bypass intended permission boundaries. At least privilege is key, but bugs can undermine it.
The sources also detailed some classic exploit types that still pop up, like blind SQL injection. Sounds sneaky.
It is. CVE 2023-42509 was an example. The attacker doesn't get direct database output. Instead, they send crafted API requests, often to search endpoints like AppSearch Artifact with embedded SQL conditions.
How do they get data out then?
By observing timing. If their injected SQL condition is true, the server might take, say, 10 milliseconds longer to respond than if it's false. By sending thousands of requests and carefully measuring these tiny time differences, they can infer data one character at a time. Usernames, password hashes, maybe sensitive metadata. It's slow but effective for exfiltration.
And the old favorites. Path traversal and remote code execution, RCE. Still a threat.
Unfortunately, yes. Older Artifactory versions had known issues where attackers could potentially use path traversal tricks, like using got-init upload path via an API call to write files outside the intended directories. If they could upload a web shell, a malicious script, to a place where the server would execute it, that leads to RCE.
And there was a more recent variant, zip-slip.
Yeah, zip-slip is a clever path traversal attack that uses archive files. An attacker crafts a malicious ZIP file where one of the files inside has a name like .sesimaliciousscript.esh.
So the file name itself contains the traversal path.
Exactly. When Artifactory, or the underlying system utility, extracts this ZIP archive, a vulnerable extractor might interpret that file name literally and write the maliciouscript.esh file way up in the etc. directory, instead of safely within the intended extraction folder.
Allowing them to overwrite system files or plant executable code.
Precisely. There was a bug bounty awarded for finding a zip-slip vector in 2024, reportedly worth $5,000. It shows these fundamental file handling vulnerabilities are still being found and are valuable targets for achieving RCE.
Okay, we've covered platform vulnerabilities, but the sources strongly argue that the biggest day-to-day threat isn't CVEs, it's the configuration crisis.
This is really where the rubber meets the road for most attacks. It's about operational errors, risky defaults, and just exposure. The scale is staggering. Tools like Shodan, which scan the internet, consistently find over 10,000 Artifactory instances publicly accessible.
10,000 just sitting there, visible online.
Visible, potentially probable, that visibility is step one for any attacker. But the really shocking finding for the research concerned anonymous access.
What did they find?
Well, historically, older versions of Artifactory, before version 7.84.3, I believe often allowed anonymous users, people with no login, default download permissions on certain repositories. That's bad enough potentially leaking internal code or libraries.
But it got worse.
Much worse. The researchers found around 70 publicly accessible instances running these older versions that were configured to allow anonymous users to upload artifacts.
Anonymous upload access on a public instance.
Yes. It's almost unbelievable from a security perspective.
No.
It means any attacker, anywhere in the world, without needing any credentials, any exploit, could simply push malicious code, a Trojanized library, a backdoor tool directly into that company's presumably trusted Artifactory instance.
That's not just leaving the door unlocked, it's putting out a welcome mat for supply chain attacks.
It's a direct engraved invitation. Just drop your malware here, and our CI/CD pipeline will pick it up shortly. It's a catastrophic yet easily fixable configuration failure.
And this ties into the other major configuration-related risk, data leakage via secrets and artifacts. Even if an attacker only gets read access, maybe to one of those 10,000 exposed instances, the damage can still be immense.
Absolutely, because developers, under pressure, sometimes make mistakes. They accidentally hard-code sensitive data directly into the source code, which then gets compiled into the artifacts stored in Artifactory.
What kind of secrets are we talking about?
Everything. API keys for cloud services, database connection strings with passwords, private SSH keys, tokens for third-party services. If it's needed at runtime, someone, somewhere, has probably hard-coded it at some point.
So if an attacker compromises an Artifactory instance, even just with read-only access,
They download everything they can get their hands on, JAR files, Docker images, configuration files, and scan them relentlessly for these embedded secrets. Finding a single AWS access key inside a Docker image stored in Artifactory can be the foothold they need to pivot and compromise the company's entire cloud infrastructure.
so Artifactory becomes the intelligence source, the stepping stone to a much bigger breach.
It's the perfect launchpad. That's why scanning artifacts for secrets using tools like Xray's advanced security isn't a nice-to-have anymore. It's fundamental defense against this kind of lateral movement.
Right, let's connect these threats to real incidents. The August 2024 cache poison campaign using CVE 2024-6915, what did that actually look like for the victims?
It was chaos for their development pipelines. Teams suddenly saw builds failing unpredictably. Worse, some potentially saw unauthorized code getting pulled into their builds because the attackers had corrupted the metadata cache on exposed, unpatched Artifactory instances.
So the trust in their own infrastructure was broken.
Completely broken. They couldn't rely on getting the correct, vetted dependencies. It meant emergency patching, rotating credentials potentially exposed by malicious payloads, and painstakingly auditing every recent build to see what might have been compromised. Huge disruption, massive loss of productivity.
And the 2023 secrets exposure incident that reinforces the configuration angle, doesn't it? Especially
Yeah.
permissions.
Absolutely. That analysis pointed directly at overly permissive deploy permissions assigned to users or CI/CD processes. Basically, roles that allowed pushing artifacts were too broad.
And that led to artifacts with hard-coded secrets getting into repositories where they shouldn't have been.
Yes, and the study found this affected something like 15% of the repositories they scanned. It's a stark reminder that simple RBAC errors, not just complex exploits, are a primary driver of supply chain risk when using platforms like Artifactory. Get the permissions wrong, and you leak secrets.
Okay, let's crystallize this. Can you walk us through the typical stages of an Artifactory-enabled supply chain attack, putting all these pieces together?
Sure, it usually follows a pattern. Stage 1. Reconnaissance and initial access. The attacker scans the internet using tools like Shodan, finds a publicly exposed Artifactory instance, maybe they find a leaked token on GitHub, or exploit a known vulnerability, or even find an issue in the SSO integration. The goal is just to get that initial foothold, often with fairly low privileges.
Okay, they're in the door. Stage 2.
Internal foothold and privilege escalation. Now, they use the Artifactory API, especially search functions, to explore. They download internal artifacts, proprietary libraries, build information. They're looking for two things: sensitive data within the artifacts, like those cloud keys we talked about, and ways to escalate their privileges within Artifactory itself, maybe exploiting a vuln like CVE 2024-4142, or hoping to find an admin token somewhere.
So intelligence gathering and looking for ways to gain more power. Stage 3.
Malicious code injection. This is where they plant the payload. If they've managed to get right access, maybe via that leaked God token or privilege escalation, they'll replace a legitimate, commonly used internal library or dependency with a poison version containing malware, a backdoor, or data exfiltration code. They put it right there in a trusted local repository.
And the final blow, Stage 4.
Downstream compromise. The organization's own automated systems deliver the attack. The CI/CD pipeline runs, needing that dependency. It pulls the now poisoned version from Artifactory, implicitly trusting it. The malicious code executes, often on a build server or deployment target that has high privileges itself.
Allowing it to steal production secrets, deploy ransomware, or establish persistent access.
Exactly. The attacker leverages the organization's own trusted automation against itself.
This sounds disturbingly similar to other major supply chain attacks we've seen, like the CodeCoff incident.
The parallels are very strong. In a CodeCoff-style scenario targeting Artifactory, the malicious artifact planted in Stage 3 would be specifically crafted to run within the CI/CD environment and steal sensitive information available there, like temporary cloud credentials, environment variables containing API keys, secrets used during the build.
So it uses the CI runner's own privileged context to harvest valuable data.
Precisely. It weaponizes the trusted build process itself. The compromised Artifactory artifact becomes the delivery mechanism for stealing credentials from the heart of the DevOps pipeline.
It's clear Artifactory is a powerful target, but it can also be a powerful defender, right? Especially against attacks aimed at public package registries.
Absolutely. That role as a central proxy, the remote repository function, is a key defensive shield if used correctly. By forcing all developers and builds to pull external dependencies through Artifactory.
You get that inspection point.
You get that inspection point. You integrate Xray, and suddenly you're scanning every incoming package from NPM, PyPI, Maven Central, etc. for known malware, vulnerabilities, typo squatting attempts before it gets cached and distributed internally.
So it acts like a firewall for your software dependencies.
Essentially, yes. The sources mention specific examples where, during known malicious campaigns targeting public registries like NPM, integrated scanners within Artifactory setups were able to block a very high percentage, like 80% of those known bad packages automatically. That's a huge win, preventing widespread compromise.
Okay, the risks are clear, the mechanisms are clear. Let's talk solutions. Strategic mitigation. Given the token trap is such a huge issue, fixing that has to be top of the list.
It absolutely must be. The number one action is to stop using default, overly broad identity tokens generated via the UI for automation. Full stop.
So what's the right way?
Use the dedicated API endpoint for token creation. It's XSCP1 tokens. This API forces you or allows you to be much more specific. You need to generate scoped tokens.
What does scoped mean here? How is it different?
It means you define exactly what that token is allowed to do and where. You grant it only the minimum necessary permissions, maybe just read-only access to a single specific repository needed for a build, or write access only to a particular deployment path.
And crucially, you limit its lifespan.
Yes. You set a short expiration time. Maybe the token is only valid for 1 hour or 30 minutes, or even dynamically generated just for the duration of a single CI/CD job run. If a short-lived, narrowly scoped token leaks, the potential damage to the blast radius is dramatically reduced. It's a small change in process for a massive security gain.
Seems like a no-brainer. What about securing human access and moving away from long-lived machine credentials altogether?
For humans, mandate single sign-on, SSO, integrated with your corporate identity provider, and enforce multi-factor authentication, MFA, everywhere, no exceptions. For machine-to-machine communication, the gold standard to aim for is using protocols like OIDC, OpenID Connect.
How does OIDC help eliminate tokens?
With OIDC, your CI/CD runner doesn't need a long-lived Artifactory token stored somewhere. Instead, it can authenticate using its cloud identity, like an AWS IAM role or Azure Managed Identity, to securely obtain very short-lived temporary credentials directly from Artifactory, valid only for the specific task it needs to perform right now. The whole problem of managing and potentially leaking persistent tokens just disappears.
Okay, that handles credentials. What about those 10,000 exposed instances? Network hardening?
Non-negotiable. Network isolation. If your Artifactory instance holds private code, internal libraries, any sensitive IP, it simply cannot be directly exposed to the public internet, period.
So deploy it where?
Inside a private network segment, a private VPC in the cloud, or a secured zone in your data center. Access should be strictly controlled via VPNs, private network links, and very tight firewall rules, ingress and egress. If you need some public interaction, like for remote repository caching, expose only a hardened load balancer or proxy specifically configured for that limited function, protecting the core instance behind it.
And the fix for that horrifying anonymous upload issue?
Simple but critical. Audit and explicitly disable anonymous access to all repositories that shouldn't have it, especially write access. This is usually just a configuration toggle, check it now. And alongside that, maintain a rigorous, timely patching schedule. Known critical CVEs, like that cache poisoning one, are actively exploited. You have to stay current.
All right, let's talk about shifting security left, embedding it into the pipeline using Artifactory and Xray.
This is about making security proactive, not reactive. First, enable continuous scanning with Xray. Every artifact, whether it's built internally or pulled from outside, should be scanned immediately upon entering Artifactory. Find problems early.
And just scanning isn't enough, right? You need enforcement.
Exactly. You need policy-based security gates. Configure Xray policies to define what's acceptable. For example, block any artifact with a critical or high-severity CVE. Block artifacts with incompatible licenses. block artifacts containing hard-coded secrets.
And these gates actually stop the pipeline.
Yes, you configure them to automatically fail the build or prevent the promotion of a non-compliant artifact to the next stage, like staging or production. Artifactory stops being just a library and becomes an active security enforcement point, automatically upholding your standards.
That also helps with traceability, doesn't it? Knowing where things came from.
Absolutely. Artifactory's metadata, when used properly, capturing build info as CM links, provides crucial artifact provenance. You can trace a binary back to the exact source code commit, the build job, the developer. That's invaluable for audits and incident response.
But even with all this, things can still go wrong. Tokens might leak. So monitoring and response.
Crucial. You need proactive monitoring. Start with audit logging. Regularly review Artifactory's access logs. Look for anomalies, logins from unusual IP addresses, access attempts at odd hours, sudden large spikes in downloads from one user or token, potential exfiltration, repeated failed logins.
And if you do detect a breach or a token leak,
You need a predefined incident response plan specifically for Artifactory compromise, especially token leaks. It needs to be immediate. Revoke the compromised token instantly. Rotate all potentially related credentials, because you might not know the full scope, and begin a forensic analysis of the audit logs immediately to understand exactly what the attacker accessed and did. Speed is critical to contain the damage.
Okay, let's try and wrap this up. JFrog Artifactory, clearly essential for modern software development, provides that needed speed and control.
Indispensable, really, for many organizations.
But the core message from all this research seems to be that its greatest strength, that centralization, is also its greatest point of potential failure, especially when humans make mistakes.
That's the paradox, isn't it? The architectural power is immense, but it intersects directly with the risk of configuration failure. And the data we discussed is stark. Something like 70% of breaches in this area tie back to those configuration issues.
Overly permissive tokens, anonymous access left open, public exposure. Not usually the super sophisticated zero-day attacks.
Right. The platform itself provides the tools for strong security, but they have to be used correctly, consistently. Discipline matters.
Which brings us to the final thought. Artifactory, especially with Xray, gives organizations the technical means to enforce security governance, those automated policy gates we talked about, scoped tokens. The tech is there.
It is. The capability exists to automatically stop insecure code from progressing.
So, if the technology allows for non-negotiable security gates, what's the real barrier? Is it organizational? Is it diplomatic? What needs to change in the relationship between the DevOps teams who are pushed for speed and the security teams to ensure those critical gates are always enforced without workarounds, even when project deadlines are screaming?
That's the million-dollar question, isn't it? It's less about buying more tools and more about embedding that security discipline and governance deep into the culture and processes, right at the heart of the digital factory floor Artifactory. That cultural shift, ensuring security isn't bypassed just this once, that's the ongoing challenge.
Something for everyone to think about. Thanks for joining us for this deep dive into securing Artifactory. We'll catch you on the next one.